Welcome back, everybody. We're going to talk about part 2 of RE5, Compound Exponent Rules. Again, part 2 is just a continuation of part 1, where we are just going to tackle the other half of the problems. This is an optional video, so if you feel like you have enough practice and you know what you're talking about, you can move on to the homework at that point. Otherwise, stay here and we'll keep working through some problems and get you some more practice. Here's the first problem that we see. We're just asked to simplify here. So when we see this, first thing I like to notice is I see my parentheses kind of happening over here. So let's deal with those parentheses first, and we're going to try to make this piece look as simple as we can, and then at the very end we'll bring this piece in. So looking at this first piece, again, parentheses always mean multiply exponents. So I'm going to add in the exponent that I was missing here to make sure that everything inside has an exponent, and then from there I can multiply those exponents. Remember, when I do this, the base is never going to change. So 5 was the base there. The only thing that changes are my exponents. So I'll have 5 to the third and r to the 15th. Now, once this inside is as simple as it can be, then we want to sit there and bring in this r to the negative 2. Now, to combine these, we essentially have two piles of r right here. One that has 15 r's on it, the other one that has a negative 2. If I were to put those onto the same pile, then I would have 12 r's altogether, right? Because 15 plus a negative 2 would be equal to, not 12, I need 13, right? So this would be to the 13th power. Now, officially, this is a good answer, and in some situations, this will be what your answer will look like, but sometimes they might actually ask you to go a little bit further. And if they did, we would have to sit there and simplify 5 to the third. Now, of course, 5 to the third just means 5 times 5 times 5, which of course ends up being 125. So another answer that would also be right would be 125 r to the 13th. Either one of those is absolutely acceptable for you. Here's another problem for you. X to the first times x to the 7th. Now, when we're looking at that problem, one thing I notice is this one doesn't have an exponent on it, so I'm going to put a 1. Essentially, we have 3 piles of x's right now. This one, of course, has 4. This one has 1. This one has 7. If I put all of those piles onto the same pile, then I would just need to add the exponents to figure out how many there are. 4 plus 1 gives us 5. 5 plus 7 is going to give us 12. I'll have 12 x's total, and we're done. Moving on to the next problem. Now, this is how I like to think about this problem. See how this negative's on the outside here? We're just going to separate that off for a second. We'll deal with that negative all the way at the very end of this problem. Now, to do this, again, we see parentheses here, and parentheses always tell us to multiply our exponents together. The 4 is, of course, missing an exponent, so we're going to put in that 1 to start. When I distribute the 3 to those exponents, I will end up with 4 to the third and c to the 21st. Now, one thing I can do to make this simpler is let's evaluate 4 to the third. Now, that, of course, means 4 times 4 times 4, which should be 64. So I'll get 64c to the 21st. Now, this negative, again, this is because it was on the outside, is now allowed to just drop right down in front, which would make this our final answer, negative 64c to the 21st. If the negative is outside the parentheses, you just got to drop it all the way down to your answer. If it's inside, we got to think a little bit more. And we did see, I believe, a few problems where it was inside in part 1. So if you haven't seen that yet, make sure you go back and pay attention to that. Here's another problem for us to consider. Again, we have parentheses, so we are going to put in any missing exponents, and then we're going to multiply the exponents, of course, not actually the numbers. So I will get 4 to the third, because 1 times 3 is 3, a to the 6th, 5 to the third, and b to the 9th. Now, this is a great answer here. It maybe could go a little bit further if I actually multiply 4 to the third out and 5 to the third. So let's do that. 4 to the third would be 4 times 4 times 4, which is 64. And 5 to the third is going to be 125. Right? Of course, that means 5 times 5 times 5. 5 times 5, 25. 5 25s is 125. So again, two answers that are absolutely equal to one another. Just be prepared. You might have to work with either one of those on your tests and quizzes and on your homework. Another problem for you to consider. Again, let's try to simplify the part with the parentheses first, and then we'll try to take this green idea and this orange idea, and we'll try to put them together. So, looking at this, parentheses mean multiply exponents, so I'm going to multiply the 3 and the 4, and the 3 and the 2. 3 times 4 is 12. 2 times 3 is 6. Now, we haven't seen a multiplying one quite like this yet. One thing that you need to remember, when you multiply fractions, we just multiply straight across. So, when we do that, on top, 3 times m squared, or m to the 12th, is going to be 3m to the 12th. On the bottom, 8m to the 5th times n to the 6th is going to be 8m to the 5th, n to the 6th. Now, once we've gotten to this point, we got a little bit of work to do. If you notice, we have m's up top and m's on the bottom. And we don't ever want that to happen. We always want to get all of our m's onto the same pile. Now, one way to think about this is to actually draw this out. M, 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 M. There's 12 of them. Those are my m's that are on top right now. On the bottom, I have 5 m's. We know that every time I have one on the top and one on the bottom, they cancel out. Cancel out, cancel out, cancel out, and cancel out. And the question is, how many do we have left? Looks like 1, 2, 3, 4, 5, 6, 7. And those are on top. So I'm going to have 7 m's up top and no m's left on the bottom because they all canceled out. Another way to think about that is if, like, the 12 m's here, we're going to fight the 5 m's down there. We know the top would win by 7, so we'll keep 7 on the top and be done. Let's keep rolling along here. Now we see a problem that looks a little different. If you notice, this one now has the negative sign inside the parentheses. So we need to deal with that separately. So here's how we are going to approach this problem. In math, we can take this negative and we can move it to the top of that fraction. So let's do that. I'll have negative 4 over x, and this is being raised to the third. Now, when I come over here, we know that our exponent rules tell us that when we have parentheses, you got to take whatever's on the top and raise it to the third power, and take whatever's on the bottom and raise it to that third power. So, in this particular situation, we'll have negative 4 raised to the third power, and on the bottom, I'm going to have x raised to the third power. Now, to evaluate that, negative 4 times negative 4 times negative 4, let's use our calculator to verify. Negative 4 times negative 4 times negative 4 is going to give us a negative 64. And of course that makes sense, because when I have a negative times a negative times a negative, two negatives are going to make us a positive, but when I multiply that by another negative, I'm going to get a negative at the end of the day. So my final answer will have a negative 64 up top, and I'll be left with just x to the third on the bottom. And that's it. Looking at our next problem, again, we have another multiplying one here. Now, this was easy before when these were both fractions because we just multiplied straight across. And in fact, we can actually use an old math trick to make them both into fractions by putting z to the 8th over 1 to start. Now, to work through this, we again multiply across the top. 1 times z to the 8th would be 1 z to the 8th. And 1 times z to the 7th would be 1 z to the 7th. Now, at this point, we have z's up top and z's on the bottom. We want to make sure we get those onto the same pile. Here's how we're going to do it. Remember, in our previous example, when we thought about if these two were to fight, right? If there was 12 here and 5 here, we would have said the top would win by 7 because there's 7 more on the top. In this particular problem, we now have z to the 8th up top and z to the 7th on the bottom. So if I were to ask you who would win, hopefully you would tell me the top would win because there's more. How many more are there? There's just one more. So at the end of the day, there'll be one z up on top, and on the bottom, my z's are going to disappear. Now, this is a good answer. Sometimes we'll see it look a couple different ways. Sometimes you'll notice that the ones don't show up because they kind of cancel each other out. So I might just be left with z to the first as an answer. Or sometimes they don't even put the first up here, and they might just say z. The thing you need to know is that all 3 of these are good representations. They're all correct. And you got to be prepared to see any one of those 3 come up. Oh, this is my favorite kind of problem. The reason is it's easy. Remember, anytime you have something raised to the 0 power, this is a special property in math. What a lot of students will try to tell you is that this is 0, and that's not true. Never is, never will be. Anytime you see something raised to the 0 power, what's always true is that whatever is raised to that power is always equal to 1. So 3 over 4 raised to the 0 will just be equal to 1, and we're done. Here's another one. We have 5m to the negative 3rd times n to the negative 4th. If we're looking at this and we're saying, well, what can be simplified here? Well, of course it's the fact we have negative exponents. We know we're not allowed to have negative exponents in our answer. So in order to fix them, what we want to start by doing is just making a fraction. Once you've made a fraction, anything with a negative exponent can be moved to the bottom. And when you move it to the bottom, that exponent is going to become positive. Now, notice one thing. We did not move the 5 here. The 5 is going to stay on top of our fraction because the 5 did not have a negative exponent. So on the bottom, we'll now have m to the 3rd and n to the 4th. And we're done. That's it. This problem we already worked in part 1 of the video. So I think we got 2 left here, so let's take a look. Here's another good parentheses one. And what you should be thinking to yourself is parentheses mean multiply exponents. So first let's put in any missing exponents. We're missing an exponent on the 3. So we'll put that in. Once we've moved that in, now we are going to multiply the exponent on the outside by every exponent on the inside. So I'll end up with 3 to the 5th, x to the 20th, over y to the 30th. Now that's a good answer right there, and you might see that as a final answer. Sometimes, depending on the problem, you might actually see 3 to the 5th multiplied out. So we should make sure we can get that too. Easy way to do this is to use a calculator. 3 to the 5th power, or 3 times 3 times 3 times 3 times 3, is 243. So you will be left with 243 x to the 20th over y to the 30th. And that's good too. Either one of those 2 answers is going to be okay and acceptable for us. Last problem for part 2. Here we see we have negative 6 times 3 to the 0. 3 to the 0 we know is really just equal to 1. Remember, anything to the 0 is equal to 1. You can check that on your calculator too. If you just type in 3 to the 0 and hit enter, notice how it spits out a 1. So now we're being asked to take 6 and multiply it by 1, or negative 6 times 1, which would be a negative 6, which would be our final answer. Thank you for taking the time to watch this video. If you have more questions, please be sure to reach out. Have a nice day.